Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your Unit 8 homework. Question 1, the digital multimeter, DMM, is the most common measuring instrument used by technicians. That's true. Next question, question 2, a digital multimeter uses a moving pointer and a printed scale. That's false. Remember, an analog meter is going to have that moving needle for full-scale deflection. And then you have to interpret the actual reading where that moving needle intersects the scale of what unit you're measuring. Question 3. The pointer deflector of a moving coil meter movement is directly proportional to the amount of current in the coil. That's true. Question 4. Most voltmeters are multi-range voltmeters. Question 5. The ohm meter must never be connected to a circuit when the power is turned on. Question 6. In an oscilloscope, which control is used to locate the position of the trace if it is off the display? That's called the beam finder. Next question, question 7. When the ohm meter leads are open, not touching each other, the ohm meter indicates infinitely high resistance. So an open circuit is a very large resistance, and a short circuit, remember, would be zero resistance. Next question. Digital multimeters are generally easier to use because they eliminate human error that often occurs in reading scales on an analog meter. Next question. When an ohm meter is connected to a circuit in which power is on, the ohm meter can be damaged. Always please remember, if you're on the ohm meter section of your digital multimeter, you do not want to measure live voltage. Next question, when measuring a fuse with an ohm meter, a good fuse is going to measure 0 volts because remember, the thermal linkage, the thermal element inside of a fuse is going to pass current, so that's going to represent 0 ohms of resistance. Next question. Which of the following is a widely used piece of test equipment? That's called the oscilloscope. And please remember, the oscilloscope is, I like to call a graphical voltmeter, where we're measuring units of voltage on the y-axis against units of time on the x-axis, and we get a picture of what the waveform looks like. All right, thank you.